Hi everyone, this is Nočnica Nica. I wanted to welcome you to my talk, which is on the perils of serverless observability. It's a talk I'm super interested in doing. It's something that I work with every day, and I work with a lot of people who are facing pretty unique challenges. And so I hope it's useful to you. I'm super excited to be participating in Serverless Days again. It's a great group, and so yeah, thank you so much for coming out. Uh, Nika is fine if you're having trouble pronouncing Nočnica. I'm a dev advocate at New Relic. You can find me on Twitter at serverlessmom and on Twitch at Nočnica. Um, I this version of the talk is pre-recorded. I will be available in the chat throughout the talk if you have questions. I want to hear from you, and of course, do feel free to mention me or DM me on Twitter to go into this. I too get on Twitch on Tuesdays and Fridays if you want to talk more about this topic. It's basically my specialty. What I spend a lot of my time doing Twitch streams about when I'm not building fun robots is AWS and serverless. So we're going to do this. Now, I will just mention I am the New Relic advocate for serverless. Did you know that New Relic monitored your serverless apps? Well, it does. So we're not going to. In no way is a product pitch or really anything else about this talk is about New Relic. As long as you're aware that New Relic does serverless monitoring, then my work there is done for New Relic and my paycheck is made. So let's talk about the subject of this talk. Serverless observability can be hard, like surprisingly hard. And this is really what I experience when I talk to developers who are using serverless currently. A very common sentiment that I hear is something along the lines of, things are going good, things are running well on our stack, but we don't know exactly what's going on inside of there. When I mention something like, hey, you just suddenly start getting a 503 back from your API gateway, what's causing that, right? Where's the first place you look? It's a complicated question and it can start to stress people out it starts to stress everyone out. It's not something that, just you are aware of as an issue. Um, so to do a little bit of definition in terms here, to make sure that we're kind of all on the same page, I'm going to squanch my video just a little bit to make sure that it's all coming through. Very often when I talk about serverless, we really are talking about serverless on Amazon Web Services and specifically with their serverless compute product, AWS Lambda. Now, serverless is a lot bigger than just Lambda on AWS, and serverless as seen as a goal is much bigger than just AWS services. So that's fair, that's true. This is going to be sort of my area of specialty, and it's often what I'll use kind of synonymously. This talk is going to be much more about kind of the high level strategy and more general tactics that we can use to increase our observability. So it's not going to be too specific to this particular tool, though you will hear, Lambda will slip out and CloudWatch will slip out as, sort of the general things that I'm talking about. So let's take a minute to define what observability is, right? Observability is this huge buzzword specifically on the West Coast of the United States. Other places, less so. As far away as Chicago in the middle of the United States, it's like, nope, we don't, it's not the term that we use. Do you mean monitoring? Are we talking about some AI thing? Is it a product from a particular company? Observability is, I think of it as sort of like the first half of your mean time to resolution. Observability is the amount of time between knowing that you have a problem and knowing what to do or fully understanding that problem and coming up with some path to resolution. So, it's possible to have very low observability even when fixing a problem. If you have some, error or something's flapping or it's not available, it's not acting right, and you restart your bare metal server, you solved the problem, you resolved it pretty quickly, but your observability is quite poor. Most of the time, though, right, we really can't fix something until we understand at least where it is. So that is, observability is a part of that. And it comes to the fore a little more when we're dealing with microservices, when we're dealing with a more atomized environment where we have lots of little components. there's nothing really to reset, right, in serverless world. So, there's not really a way to fix something without understanding it. Okay, let's get to the problems. Let's get to why observability can be difficult. So, the first source of trouble is that everybody has their own little island. Everybody's their nation unto themselves. The whole goal of serverless and the whole goal of microservices is that we're empowering small teams to deliver services on their own, which hopefully are super useful to the organization, do whatever they need to do in a really efficient way. And because they're this microservice, they're fully in control of it and they understand it really well, right? Because they just control this one component of it. However, as you get large groups of people, large numbers of teams that are all delivering their own microservice, whereas previously we had this big scary monolith, now we have this Tower of Babel, where everybody understands their component, but nobody's necessarily understanding how things work together. There are a lot of tools to try and resolve this, to try and get us into a better situation with our observability. Obviously, the cloud platforms themselves try to give you some insight into what's going on in the stuff that you wrote, but there's not one single key solution. So I was talking about AWS X-Ray over the last few weeks because we had a little X-Ray integration in New Relic, and it was surprising how many people thought of X-Ray as really this like observability Santa Claus, that it was like, X-Ray can tell you if your, average time to resolve something is slipping or if this is happening, which, X-Ray really isn't for that. It's for seeing the connections in a single request one at a time. So, there's certainly not one like tool and not even really one like browser window that can give you a good insight into how these stacks are working. So, this is not specific to AWS. This is almost just an implicit thing with this kind of service that, when you're able to create stuff that involves components from multiple products and works together quite seamlessly, the ability to get insight into how that's working, it can drop. And so you can really start to see problems there. Another component is that the tools that we have to give insight into how something performs is not particularly standardized. Again, I'm not trying to pick on AWS X-Ray here, but it does stand out to me that in AWS X-Ray, come in. I think I'm getting a cup of tea here, so it's fun, live recorded stuff here. Solutions aren't standardized, so again, not to pick on X-Ray. When you look at stuff, we have now a standard for storing traces. Thank you so much. For storing traces, which is W3C standard, but X-Ray doesn't use it. And a bunch of other observation tools don't use it. So while we can get really nice traces and metrics from a few places, actually getting those into a nice consumer to handle those is tricky, okay? So let's talk about solutions. Let's not just complain, let's talk about our solutions. So the tools that we use to give ourselves insight into our stack, they really do matter. And the choices that we make, especially to use a particular tool or not, they really affect our observability. So the first one, and it's not even a measurement tool or a metrics tool at all, is infrastructure as code is a really, really basic tool for observability. When you go into a cloud console to the AWS console and you make a setting to make something work, and then you close that console, you have just, in any catastrophe, you've reduced your bust factor to 1, right? You're the only one who understands what you did and why you did it. And that really comes up during an incident, right? If you say to yourself, oh, great, I made this one change and it was just something that you did in a console somewhere, you're really not going to have any ability to look back at that and have your whole team know that and be aware of that. There are several paths to get to that infrastructure as code place. On AWS, CloudFormation is going to be the way that those things, they're going to create CloudFormation templates eventually. Something that I hear all the time when people talk about, what's the best tool to do your infrastructure as code, to template your components. And just to review, when we say infrastructure as code here, what we mean is rather than going into the console and saying, hey, we're going to make a setting, or we're going to say, create a new service, or create a new Lambda, or create a new table, we're going to use a template that says all of the stuff that we want to have happen on our stack, and then we're going to update that template when we have changes. And much more important than what tool you use for that, I used to work for Stackry, which is a great tool for doing the same kind of deployment and templating. Much more important than your pick of which tool is that you use a tool, and that really matters quite a bit more. So yeah, a lot of these are going to go through CloudFormation, but I really just recommend you doing them. The basic thing here, right? It doesn't matter if your template format is easy or hard to read or whatever. The fact that you're going to have some kind of commit history that shows what changes happened when and hopefully who made them is really going to cut your time to understand an incident or a problem. So another piece, something I think about a little bit, is that when I say, hey, it's the amount of time it takes you to know you have a problem to understanding that problem, that really gets us into this world of incident response, right? Where we're trying to understand, like, why is an error being raised? Why is the service falling down? That kind of thing. We also want to have some observability when things are going well. And part of that is stuff like health checks and other kind of dashboarding to keep an eye on sort of trends and performance. But this is another component. Again, it's not a monitoring or observation tool, but Canary deploys can do a ton for your observability because they can increase your understanding of what changed when and how that might have affected things. So they also increase your ability to do experimentation, which again can increase your understanding of how your stack actually works. So you can use them from right within CloudFormation. You can use Aliasing to try new versions of your serverless compute functions. So I would say, it may seem funny that Charity Majors is one of the big superstars of observability and certainly thought on observability is often talking about deploying on Fridays, but it's really not that surprising, because the fact is that you really want to have that kind of insight into how you're performing, to say, hey, this is what's going on inside my stack, and that's why you're able to do deploys on a Friday, because you're able to see and roll back quite effectively. So yeah, refusing to deploy on a Friday may indicate that you have an observability problem, because you can't deploy at 8 o'clock in the morning because you know that if there's a bad enough problem, it's going to take you all day to figure it out, or take you till 4:30 p.m. That's a serious thing, and so that's worth considering. So planning ahead for observability. I like this picture. I don't know how many in the audience are Animal Crossing players, but the fact is that you really want to have a plan, because while this orchard looks really great in Animal Crossing, once the character tries to go and pick any of these fruit, they're not going to be able to see the character at all. That's just the way the camera angles work. So you want to have a little bit of a plan ahead. So structure in what we're recording can help us out quite a bit. These are Penrose tiles. If you're interested in structure and chaos, it's neat. So in this case, usually what I'm talking about is structured logging. So Yan Kui, who's a very smart a serverless person, wrote some great stuff about the necessity to use structured logging within your AWS components. So we're seeing an example of that here. And sorry if this type is a little small. It may not be big enough to be useful to you, but essentially, instead of just dumping single lines into the console, we're saying, hey, we have these specific objects that we want to modify and then log as a whole. So instead of just having single lines, which you need then to go parse with a regex, this is a nice object which you can parse automatically. And that just makes your situation so much easier when you're diving deep on a problem. Beyond that, so structured logging can help us get that very close microscopic view of why something happened on every single event. But a high-level view is also a critical piece. So, one of the ways to think about that is something like alerting, right? Alerting is kind of the highest level view that you have that there may be a problem. My advice for alerting, especially in the serverless world, is first of all cost. I may kind of read these directly. Sorry, this is the only text-heavy slide in this one, but I do have a lot of thoughts on alerting. Cost can combine a lot of your measurements into a single measurement. So cost can tell you things like, you might say, hey, I have a great response time right now. Maybe I have no errors. Maybe what your Lambda is doing is returning very quickly a not correct response without ever even checking with the database. Well, in that case, everything will look great. Your response time will look great. Your throughput will look great, but your cost will suddenly drop unexpectedly. And obviously, on the other side, right? When you have costs skyrocketing, costs are skyrocketing, so you want to know about that. I would say alerts and alert fatigue require at least a monthly check-in to make sure that our alerts are still useful. So this is just, this can be 15 minutes. It can, once this coronavirus is dealt with, it can be around the coffee machine and just a conversation to say, hey, what alerts did we get and did they make sense this month? One question to ask is, kind of do your alert of alerts. Like, what is the alert rate right now? How many alerts were sent? And does it make sense that are we at a higher or lower rate than we were a few months ago? So the last piece is thinking about high and low thresholds. Because, the fact is, right, if you suddenly have 10 times the previous number of requests in a minute, that is a real problem. But if you have suddenly a drop, 0.002x, that is also a problem. So it's worth very, very frequently to set high and low thresholds. I mentioned that about cost, right? That we might want to set high and low thresholds for measuring cost. But that's really an issue kind of all over the place with measurement of concerns. So, throughput's only jobs it may be that are, what's sending us events is not working. Even something like, an example of one that probably goes in one direction is like memory usage on the Lambda, right? We probably just want to see when memory usage is getting high. Well, if it's getting very low, that could be a lot of things. It may not be that much of an issue. So beyond talking about the tools that we use and how they matter, the usability of those tools also matters. How good a tool you have, that counts for something. If observability is the time it takes us to understand something, if we have a poor user experience, that really can affect, how quickly we can understand. If we're clicking a lot or we're sort of looking at a dashboard or data display that doesn't make sense to us immediately, that will affect your time to understand a problem. So, this is an example of sending serverless data to Prometheus and Grafana to get really nice, I might call them New Relic style or sort of, the level that we have expected from an APM tool to really give us a really quick insight into what might be going on and also to align that in time very quickly with these plot views. So, usability of your tools has a direct effect on observability. The last component I would say is that tools matter and usability tools matter, but people really matter too. When you have your two senior engineers leave, your observability just dropped, right? The new team that you have might have the same, or presumably has the same dashboards, the same logs, the same information, but of course it's going to take them longer to take that information and turn it into understanding. So when you say, hey, we want to invest in observability, we want to invest in this level of response time or able to understand incidents, any time that you spend educating your whole team on how your architecture works, sharing knowledge, developing new people to have a high degree of competence, and any effort that you spend as a manager to retain people who are really high quality on your team, who contribute a lot and also contribute a lot of understanding during incidents, those are really worth it. And, this is the sad story of development, is the fact is that people matter a lot more than any particular tool that you select. So you want to try and develop your team as much as possible. So I, again, am Nočnica. I really loved talking to y'all. Again, I'm in the chat. I hopefully was saying funny stuff while this recording played. But if you do have questions, do go ahead and send them there or look me up on Twitter, and we'll talk soon. Thanks so much, everybody.